This would be day 3 of polynomials in my pre-calculus class using the CPM textbook. Day 1 would be graphing polynomials in factored form. Day 2 would be writing equations of polynomial functions. And that brings us to where we're at today, identifying and using roots of polynomial functions. We want the students to realize that complex roots of a polynomial come in pairs that are complex conjugates. They should know what conjugates are before this, and they should know that there are zeros. We call them roots or zeros. Every real number is also a complex number, and distinct real roots are the x-intercepts. What we want them to know by the end of this is that every polynomial of degree n will always have n roots. First example would be these 6 graphs. Hopefully right away they would notice that graphs A and D are connected, B and E are connected, as well as C and F. And we want them to identify the number of distinct real roots. We'd give them some time in class to answer these and then justify their reasoning within their groups. If we look at this using the graphs from using their answers from the previous slide, as well as the graphs, they should understand that there are distinct real roots of an even degree can have as many as, or as few as 0, and as many as up to the degree of the function. As far as an odd degree function, it cannot have 0 distinct real roots. It has to cross the x-axis. This next question has them look at the graphs and compare and contrast them to find which one has fewer roots than the corresponding polynomial. It should be noted that they should see a different number of distinct roots, but the same number of total roots. Looking at the following polynomial of p of x, they should realize that there are 1, 2, or 3 distinct real roots that this one could have because it is a degree of 3. They're going to keep using this polynomial to answer multiple questions as we go through. The first question is determine the real roots of the polynomial. So they want to know what some possible factors of the polynomial are. For the rational root theorem, they would find that it is plus or minus 1 and plus or minus 5. Once they have the possible roots, they should work through to determine that there is only one factor, and that would be the positive 1. Therefore, they could split up the polynomial using long division or synthetic division to come up with x minus 1 and x squared plus 3x plus 5 as the other factor. Once they have the factored form, they should be able to work through and find the different roots. They will have to use the quadratic formula to find the other 2 roots since they are complex roots. And that would be negative 3 over 2 plus or minus the square root of 11i over 2. When they look at the x-intercept of the polynomial, the real root is the only one that crosses the x-axis. The other 2 turn out to be complex roots. With this book, we have them divided up into teams or groups so that they always have group interaction and they're always working together to find the solutions to further deepen their knowledge. So with this next question, they have to list all the possible factors, test the factors, and write the polynomial completely factored form, and then determine the roots. So once again, looking at the possible roots, you would have to go through the rational root theorem, and then you find that the roots are plus or minus 1 and plus or minus 2i. With this one, they actually have to factor by grouping, which leads to, this is the work that shows how they came up with the roots of plus or minus 2i and negative 1. Now here's an example where they start with the roots and then they have to work backwards to get the polynomial function. The work is shown below where they have to write the product of the 2, they have to distribute, simplify, and they come up with one possible polynomial of x squared plus 6x plus 10. As a closure to this lesson, I would want them to explain how the roots of the polynomial, explain what they know about the roots of the polynomial functions. Is there a way they can determine all of the roots? Want them to give examples, sketches of graphs, and then I want them to actually title this what they were talking about, which is roots of polynomial function, and then put today's date. Thank you.